Okay, in this video, we're gonna solve part B of question 8. In this part, we want to show that the tangent to the curve y equals to f of x at P and the tangent to the curve y equals to g of x at P intersect at right angles. Recall that if we want to show that two lines are perpendicular or intersect at right angles, we want to see if the slope of these two lines, the product of the slope of these two lines is 1 or not. If a product of two lines is equal to -1, this means that these two lines intersect at right angles. So our next step is to find out the slope for the curve y equals to f of x and the curve y equals to g of x. In order to find the slope, we first calculate their derivatives. Okay, so the derivative of f of x is equal to negative sine x, and the derivative of g of x is equal to the derivative of tangent x. It is equal to secant square x. Okay, so at point P, the slope for the tangent of y equals to f of x is f prime of k, which is equal to negative sine k. Similarly, 1 for the g of y equals to g of x is just g prime of k, which is secant square k. Okay, so their product f prime of k times g prime of k is equal to negative sine k times secant square k. Okay, so and from part A, we know that sine k is equal to cosine square k. So this is equal to negative cosine square k times secant square k. And because cosine and secant are reciprocal, this means that the result is -1. Okay, so the product of the tangent lines for f of x and g of x is -1. This says that these two tangent lines intersect at right angles. Okay, so they intersect at right angles.